Today, we're unpacking a concept that literally sounds like it's straight out of a sci-fi novel, but it's actually being engineered right now. We're talking about beaming electricity directly from space down to Earth. Specifically, we're looking at the architecture driving massive initiatives, like China's Space Solar Power Project. So if you want to grasp exactly how we might soon transmit gigawatts of power without using a single wire, well, you are definitely in the right place. Okay, let's dive into this by thinking about the device you're using right now. Pretty much our entire world is totally tethered to physical cables and grids, right? I mean, for over a century, the golden rule of energy transmission has basically been to get power, you need a wire. But that physical infrastructure is inherently limiting. So breaking that rule and transmitting massive amounts of electricity through thin air, that requires us to fundamentally rethink the biggest bottleneck in our current renewable energy strategy. Earthbound solar arrays are obviously absolutely critical to our energy grid, but let's face it, they suffer from massive atmospheric interference. Not to mention the unavoidable downtime caused by, well, the Earth's rotation. The second night falls or a big storm rolls in, production just drops to zero. But up in geostationary orbit, all those limitations just vanish. There's no atmospheric scattering, no weather, and no night. Up there, solar panels get intense, continuous, completely uninterrupted sunlight. It's a continuous wattage advantage that radically outpaces anything we could ever build on the ground. And that brings us to the ground solution being developed by the global scientific community. Instead of fighting the atmosphere, the strategy is to just go directly to the source. The vision here is wild, assembling massive solar arrays, literally stretching several kilometers wide, high up in Earth's orbit. These giant structures would harvest all that raw, concentrated solar energy and then beam it straight down to our local grids. It's a colossal engineering leap for sure, but the physics behind it, actually remarkably sound. Now, what's really interesting about this slide is the elegant four-step bypass that makes this all work. First, those kilometer-wide orbital arrays collect the sunlight. Second, they convert that solar radiation into direct current electricity. But obviously, we can't run an extension cord from orbit to the surface. So step 3 is where the real magic happens. The system converts that electrical current into microwaves. Finally, those microwaves are beamed down to a specialized receiving station on Earth, called a rectenna, which catches those waves and instantly flips them back into usable electricity. Now, I know hearing the word microwave beamed from space might raise a few eyebrows, but in physics, microwaves are just a specific frequency of high-energy electromagnetic waves. They actually sit perfectly within the exact same spectrum as the everyday tech we already use safely all the time. Your home Wi-Fi network, radio broadcasts, your mobile phone signals, they're all part of this same family. For space solar power, engineers are really just tapping into a specific wavelength optimized to carry high-density energy through the atmosphere with virtually no loss. And this brilliantly illustrates how we actually get those waves from orbit to a specific spot on the ground. You need extreme precision. Rather than just scattering energy everywhere, the orbital satellite acts like a highly focused flashlight. It uses a phased array, which is basically thousands of tiny, synchronized antennas working together. By actively shifting the phase of the signal across these antennas, they create a tightly directed, incredibly focused energy beam. It ensures those microwaves are targeted exactly at the receiving station with practically zero energy spilling out into the surrounding void. So that designated target waiting down on the surface is the rectenna. To catch a beam coming all the way from geostationary orbit, this receiving station has to be huge, often spanning several kilometers across the landscape. Its one and only job is to catch that highly focused microwave beam and transform it right back into standard electrical current. And once it's converted, that continuous baseload power can be pumped directly into our existing local grids, powering homes and cities seamlessly. But okay, let's address the elephant in the room. Beaming massive amounts of invisible energy from space down through the atmosphere naturally begs the question, is it actually safe to do this? It's a totally valid, crucial question. Designing a system that can transmit gigawatts of power without cooking the environment or, harming local populations is the ultimate test. And engineers behind these initiatives have absolutely made risk mitigation their top priority. Strict safety protocols are built into the very foundation of this architecture. First off, these microwave beams are geographically locked to completely isolated, designated receiving areas, those giant rectennas we talked about. Second, the energy density of the beam itself is strictly controlled. The actual wattage per square meter is intentionally kept low enough that birds or even passenger aircraft could fly right through the beam without feeling a thing. Plus, if the satellite's targeting falls out of alignment by even a tiny fraction of a degree, the whole system is hardwired to instantly shut down. Now, while the physics are absolutely proven, we do need to ground this in reality for a second. This entire technology is still heavily in the research and testing phase. It's not plugging into your house tomorrow. But the momentum is undeniably accelerating. We're seeing a fierce global race, spearheaded by countries like China, the USA, and Japan, who are all pouring resources into orbital prototypes. With recent milestones, like Caltech's successful orbital wireless power transfer test, the push to launch fully functional commercial arrays is very much on. So the crucial point is really the payoff. This global investment is driven by the chance to completely revolutionize our energy grid. Think about it. Migrating energy collection to space means we drastically shrink the massive amount of land currently needed for power plants. Even better, it delivers continuous, clean energy 24/7. It completely solves the intermittency problem of ground-based solar and wind, which could trigger a massive drop in fossil fuel use and a huge reduction in carbon pollution. It's exactly the kind of scalable solution we need to meet our ever-growing global energy demands. Still, maintaining an objective view means we have to acknowledge the very steep, very real roadblocks ahead. The sheer financial cost of launching thousands of tons of materials into orbit is astronomical. And beyond just the economics, the extreme difficulty of physically building kilometer-scale structures in a zero-gravity vacuum is staggering. Plus, there are numerous unsolved technological hurdles, like protecting those solar panels from intense, degrading space radiation, and figuring out how to maximize the end-to-end efficiency of the wireless transmission itself. Despite all those challenges, I think it really helps to look at the broader trajectory of our tech. In the past, we just inherently assumed that electricity would always need physical wires. Yet today, you probably plop your phone on a pad and charge it entirely wirelessly without giving it a second thought. We are rapidly transitioning into a wireless world. This orbital solar infrastructure, it basically takes that exact same concept of wireless energy transfer and scales it up to a planetary level. When you think about it, it's just the logical next step in our technological evolution. So, as this new global space race heats up, and as these immense engineering hurdles are slowly but surely overcome, it leaves us with one seriously profound question. Will our future cities run entirely on invisible beams of power raining down from the stars? It's a mind-bending thought, and one that could totally redefine humanity's relationship with energy forever. Thank you so much for joining me for this explainer. Keep questioning, keep learning,